In this video, we are going to discuss how to calculate resistance of a wire using the relationship between resistivity and resistance. Question 5.32. What is the resistance of a copper wire of length L equals 10.9 meter and diameter D equals 1.30 millimeter? The resistivity of copper is 1.72 times 10 to the power negative 8 ohm meter. So here in this question, I have the length of the copper wire, which is 10.9 meter. Then we have the diameter D, 1.30 millimeter, which you can write as 1.30 times 10 to the power negative 3 meter. From the diameter, we can find the radius of the wire, which is R equals D by 2. So we write 1.30 times 10 to the power negative 3 over 2. That gives me the radius as 0.65 millimeter. Then we have the resistivity of the copper, which is rho, 1.72 times 10 to the power negative 8. And we need to find the resistance R. We know that resistivity and resistance are related to each other by the expression R equals rho L over A, where rho is the resistivity of the wire, L is the length, and A is the area of cross section. For a wire, the area of cross section A is pi r squared. So we rewrite this as rho L over pi r squared. Now let's substitute all the values. Rho is 1.72 times 10 to the power negative 8. L is 10.9 over pi. And then we have R, which is 0.65 times 10 to the power negative 3 squared. So whenever you have a term which is multiplied with another, make sure you take the square using brackets so that both terms are included within the square. After you solve this, you get the resistance of the wire to be equal to 0.141 ohm. Question 5.36. A rectangular wafer of pure silicon with resistivity rho equals 2300 ohm meter measures 2 centimeter by 3 centimeter by 0.01 centimeter. Find the maximum resistance of this rectangular wafer between any two faces. So here in this question, I have the resistivity of the rectangular wafer, which is made up of pure silicon. So this is resistivity of silicon, which is 2300 ohm meter. And I need to find the maximum resistance between any two faces of this wafer. So we know that resistance R is given as rho L over A, where rho is the resistivity, L is the length of the conductor, and A is the area of cross section. If we want the resistance to be maximum, the length of the conductor must be maximum, whereas its cross-sectional area must be small. So out of the dimensions given to me here, the one with the highest value we will choose as length L, and the other two will be used to calculate area. So since 3 centimeter is the highest, I will take this as length L, so we have the maximum resistance, and these two we will use to calculate area. So we substitute these to calculate R. We have rho equals 2300. The length is 3 centimeter, which is 0.03 meter, over area is by multiplying the other two sides. So we multiply 2 centimeter, which will be 0.02 meter. To convert from centimeter to meter, divide the number by 100 times the other side. 0.01 centimeter will become 0.0001 meter. And when you solve this, you get the resistance R to be equal to 3.45 times 10 to the power 7 ohms. Or you can write this as 34.5 times 10 to the power 6 ohm, which is equivalent to 34.5 mega ohm, because 10 to the power 6 is mega, or you can round this off to 35 mega ohm. So this is the maximum resistance the rectangular wafer can have between any two phases.